So today we're going to carry on in our basics of using GIS in clinical medicine, and we're going to move forward from some basics of how to just drive the GIS, how to navigate and get around, to moving forward to linking data, and specifically thinking about linking social drivers of health data to patient data. So today we're just going to focus on some of the social drivers, and specifically, we're not going to get into the variables themselves, but we're going to talk at a higher level about where to access this sort of data, how to access this sort of data, and then walk you through technically how you put that together in a GIS. Now, again, this is just the beginning, and we are going to carry on this thread through the course of several other conversations, so you can start to build both your understanding of how this works, its strengths and limitations, and then also technically what makes sense for you, and then what you're going to need to see in order to better understand and care for your patients. So before we get into this, just a quick review. The last time we met, we were just talking about how to get around QGIS, and specifically for our purposes right now, we're working with vector data. So this is where you add the data. Again, there are many different types of data that can go into a geographic information system. There's raster, which again is more of your environmental data that is going to be continuous. It's your Earth observation data you're gathering through satellite remote sensing, among other ways, but that's a big area where those data are developed. And then, of course, if you're geocoding or bringing in address data, which we're going to be looking at next, and that is going to come in as a spreadsheet, so as a .csv, so a comma separated value field. You commonly may be working with those types of files as Excel on your computer. So that's a separate type here. That's delimited text. You might also be working with global positioning systems data, so GPS data. Anyway, there are a bunch of different ways you can bring data in, but we're just really sticking to vector data at this point. In learning how to use GIS in clinical medicine. So adding the vector data, pushing that button takes you to the source. You hit the little ... button over there, and it's going to take you to the vector dataset source. This is where it becomes very important for you to build some consistency in your data management practices and find one location that is where you're going to store your geospatial data. And then again, making sure you back this up on a regular basis as well, and some other sources. But again, when you have geospatial data and you open it up and kind of see what's going on underneath it, when you unzip it or extract it, once you bring it in from your data source, you're going to see there are all these different files. All of them are necessary. They kind of work under the surface to make the spatial data function the way that you want it to. But in terms of the data you actually add, in order to see a map, that's going to be that .shp file. So you're just going to click on that and say open. You're going to leave all the rest of the defaults as they are. There's no reason to change anything at this point, and to say add. And again, the GIS is going to pop that layer into your view. It won't always be optimal for you to see it or work with it. So again, just using some of those navigation tools we talked about before, you can right click on the layer and say zoom to layout, and that's going to pop the layout right into the middle of your view, so it's easier for you to work with. Same thing, just repeat the process with bringing in other forms of vector geospatial data. So before we brought in states, now we're bringing in counties. These layers, of course, can be dragged up and down over in this table of contents area over on the left-hand side. Again, the GIS is like a layer cake. So whatever is stacked on top can hide what's underneath. You can't see through it. So you'll have to use some just basic visualization techniques in order to make sure you can see all the data you want to work with. In this case, we made the states no fill and just a blue outline and kind of a thicker blue outline. And then underneath those, we have the county data, which is filled in green with a black outline that's smaller. And this way you can see the two layers stacked on top of each other. Now, we are, at least in the use case for today, we're just focusing on Georgia. So again, and within any of these large data sets, and generally when you're downloading geospatial data, especially from, national resources, it's going to be data for the whole country, again, in a US context, but that may not be where you're working. So that's a lot of processing power your computer's going to need to work with the entire United States. And that may not always be feasible or optimal for sure. So you may just want to either, well, we'll talk about it in just a second, but you may want to pare down your data or cut it down just to the area of interest you're working in. Again, for us today, it's just going to be Georgia. So we can use our navigation tools, we can zoom in and just pop into the state of Georgia here. Adding more data, so we can add census tracts, which again are more like neighborhoods. We can add places, which are kind of a proxy for cities, but just incorporated places. We can label our data if we want to look at it to help orient us. So if you can right click on any of your layers on the left-hand side and say show labels, this is a way we can go in and see, what cities or incorporated areas do we have on the map. I'm going to zoom in here to the Columbus area. So you can see you've got Columbus and then surrounding, all of the other municipalities of different sizes across West Central Georgia, East Central Alabama. And again, here's just a zoom in of all the different navigation tools to help you move around to get to the area of the map that you want to be working in. So I know in this group, some of you are going to be working in really rather small areas, really kind of hyper local micro geographic work you're going to be doing. So you're going to be going sub county, sub maybe even sub census tract, working within census tract. So you're going to need to use these tools to navigate to get to the spaces you're interested in working in. Okay. When you're, just again as a reminder, when you're happy with where you are at the moment, you need to put it away. You want to save your project. So if you go up to project and save as here, you can give your project a name. Again, consistency in your data management is really important with geospatial data because the data get big really fast. You're working with a lot of files. And so give it a name. It's going to save it in a QGIS project format, which you probably haven't seen before, a .qgz or a .qgs. So this, again, it's going to be a pretty small file size because it's just a directory. So again, your project is not holding all your data for you. It is a directory of where your geospatial data are stored. So keep all of these again in one place and don't move your data around if you don't have to, at least in this early stage of learning how to use a geographic information system. Okay, so now that we've done a quick review of just how to get around, we're going to talk about starting the process of linking social drivers of health to places and then ultimately to people, to your patients. Okay, so again, as I said, now we're getting into some more intensive work in a GIS. We really don't want to be working with the entire country if the entire country is not our study area. So we are going to today just look at a really simple approach for reducing your data size. It's going to be called an attribute query or a tabular query. So we're basically going to select some feature within the attribute table that is the defining feature of the area we want to work with. And we're just going to keep all of the locational data that meets that requirement. So for us, we just want to work in Georgia. And here I've gone into the state file. So I don't want to work with all the other states and territories. I just want the shapefile to be the state boundary of Georgia. So I'm going to right click first on the state layer. I'm going to open the attribute table and I can see that I have a couple of columns here, a couple of fields that are going to tell me which state is Georgia. I have an abbreviation. So you can see down there, there's GA. There's also a name field where it actually spells out Georgia. So that is the record. That's the only record I want to keep here. Okay, so we are going to go in the attribute table and we are going to select features using an expression. And we want to select those, so you're going to build a little equation. We are going to select the state name. I'm going to use the variable state name or name here. And I'm going to say, I'm going to double click on name, and it's going to fill in the name up here in the upper left-hand corner in green. I'm going to single click the equal sign at the bottom here. And then I'm going to go over to this where it's all the values for that field name. And I'm going to double click on Georgia here. So it's going to give us this equation in the upper left-hand corner of select for me all of the records where the name variable is equal to the value of Georgia. Okay. And you're going to see that it's going to select it in the table. You can see this in blue. It's going to select it in the map as well, because again, in a GIS, the table and the map are dynamically linked. So you can see that yellow outline of Georgia, meaning it's selected. And then once that's done, I can go back to my table of contents over here. I can right click on the US states layer I'm using and say export, save features as. And what I'm going to do here is that you're going to save it as an ESRI shapefile, which should be the default. You're going to give it under file name. You're just going to give it a new name. I'm going to call it georgia.shp. I'm going to leave the spatial reference system, CRS, as it is. I'm going to leave the encoding as it is. The only thing I'm going to make sure I click on here is save only selected features. So under encoding, save only selected features. I'll need to check that. Otherwise, it's just going to make a copy of the full data set. So you need to tell it, nope, I highlighted Georgia. I only want to save Georgia. And then you're going to say, okay. So when you do that, you are going to have just the state of Georgia show up. You can do this with other spatial layers as well. So here you've got Georgia showing up in the table. Here is the final resulting shapefile. But again, we can do the same thing with counties. We can do it with places. We can do it with tracks. If you think about your, if you're just working specifically in one county in Georgia, or you're just specifically working in several neighborhoods, you can query down your data. So using the same process technique, just to work with those data sets. Same thing if you're working with your patient data. Maybe there's just a specific cohort of your patients you're interested in, a specific outcome. You can query down just to look at that, just to make the data more manageable to work with. So here we've got that state boundary that resulted from our attribute query. So you just have Georgia. And again, we can do the same thing with counties. So if we open the attribute table for our counties, we talked about the FIP, the FIPS code that you'll see in a lot of the geospatial data you use for the United States. It's a federal identifier number. So there's usually a FIPS code or something with FP in it in a lot of these data tables and layers. So here I'm going to say state FP equals 13. So Georgia's state FIPS code, it's the 13th state alphabetically, so its code is 13. So I'm going to say select for me all the counties where the state FIPS code identifier is equal to 13, using the same approach we used before. And now that's going to select for me all of the counties that are in Georgia. So it's going to reduce that data layer as well. Same thing again, you just right click on your counties layer, export, save features as, make sure you're saving only the selected features. And here you go. Now, instead of working with all of the states in the US, all of the counties in the US, now we're just working with Georgia, which will be far more manageable, I think, for all of us moving forward, working many of you working on your laptops. Okay, so now that we've reduced our data to something that is more computationally manageable as we start to move into linking together multiple different data layers from multiple different sources. Now we can more easily join or link these data on social drivers to the map. So linking attribute tables or data tables to these cartographic boundary files, which are just the shape files you're looking at. Now, there's no one way to do this. But I find, especially starting out, that the National Historical Geographic Information System, or the NHGIS, is probably the highest yield location to start. One, because it holds all of our or most of our census data, going back to the beginning of the census. And then also it's set up for GIS users. So all the data are formatted in a way that's easily plug and play with the GIS. And then also there's a consistency here. Once you learn the system, it's easy to replicate for all the different sorts of data you want to use. And you'll see what that means in just a second. So in HGIS, it's free to use as well. You will have to sign up. You'll have to create a login and password, but it is free to use. So here it is. This is what it looks like. And you'll start here with get data. And it's going to ask you to apply filters to your data. So, of all the data it has from the US Census, going back to the beginnings of the census, and for all these different geographic levels of the United States, what do you actually want here? So you're going to choose your geographic levels, the years, you can use the topics and the data sets. You're going to have to play around with this. Again, it's a really large resource, and it takes a little practice to get used to getting it to run in a way that works for you and the data you want. So don't think this is a one and done thing. Like it takes. I've played with it a lot for many years, so I'm really comfortable with it. But you're going to have to do the same. So if we just even start with geographic level, you can see that you can do everything from the nation. So that would be like one data value that would just apply to the entire country, or you can get state level data, county, all the way down to more micro geographic levels. You can then go in and choose. So for example, what in terms of what topic I want to look at, I'm going to start with just urban, rural, and farm status. So I want to know for each county in Georgia, what percentage of the population is classified as urban, what percentage is classified as rural, and then what percentage gets classified, like what does our farm status data look like? There are a number of ways to look at geographic kind of rurality, or that rural urban continuum. This is just one example, but as a lot of people who will be looking at this video are focused more on rural clinical medicine, I want to make sure that you know that this is in there as just one option. So I'm going to look at the county level. I want to look at the most recent decennial census data we have, which will be 2020. There is also sample data that occurs between the decennial census data. So that's from the American Community Survey. Something else you can also look at, but I'm just going to start here with the most comprehensive data, which will be the decennial census from 2020. The topic I'm going to look at is urban, rural, and farm status. And then what it's going to do is, as you make these selections, it's going to start paring down the data that meet these requirements. So here at the bottom, it's telling me that, okay, so there are a couple of different data tables that would meet my requirements. But then there's also a couple of GIS files. So these are your cartographic boundary files that meet my requirements. There's 0 time series tables. We're not going to talk about time series tables at this point, really just the source tables, which is just like what would be like your CSV or Excel file, and then the GIS files, which would be your shape file, your cartographic boundary file. As a general rule of thumb, I think it's a really nice option here that the NHGIS has a field called popularity. So you can see how many people are accessing these particular files. So usually at this early stage, at least, in learning to use GIS, whatever is the most popularly accessed file is probably the one that you're looking for. So we're going to go with this P2 that is from the 2020 census, urban, rural, and farm residents, and we're going to select that one. Okay. And so here we're also then going to click over onto this GIS file. And again, you can see popularity that the 2020 county tiger line, which is the kind of the name for the US Census cartographic boundary files. That's the most popular shape file. So that's the one you want. So you've got your data table and you have your cartographic boundary file. And so that's what you're going to see here in your data cart. You've got a source table, which is going to be your demographic or social drivers data, and you're going to have a GIS file, and you say continue. It may ask you to select the geographic extent. So again, this is data for the whole country. In some cases, you may have to go in and say, yeah, I just want the data for Georgia. It won't always be the case, but when you see that option, that is what it means. Okay, so we're selecting Georgia. We're going to use a CSV, and you notice here the comma delimited, they're telling you this is best for GIS, because again, the NHGIS is really developed for GIS users. So you click on that, and then at the bottom, it gives you the option to write a description. Now, I find this very helpful to annotate or make a note for myself of what exactly did I pull in this data request. And that way, because the NHGIS keeps up with it for you, you'll see that you can have like a running basically catalog of all the data you've pulled. So you can either go back and re-grab it if you need it, or you can make additional changes moving forward. So like, okay, so I grabbed county level data for urban and rural status, but maybe this in the next data pull, you want to look at census tract level, et cetera. Or you want to look at state level across the United States. So it helps you just organize yourself a little better. Okay. Now, what you'll see at the top is your data extracts. And for download data in that column, once these are ready, you'll see it's completed in the status column, and you can just click on the green tabs to download the table and download the GIS files. Now, what you're going to see is that it's going to come into your downloads folder, or hopefully then you move it to wherever you're managing your data. It comes zipped up or compressed. Even the CSV files do, because not only is it the data table, but they give you a code book. So they're compressed, they're downloaded together. And then the shape files are multiple files that are together, and those are zipped up a couple of times. So you're going to have to extract the data. So we'll start with the CSV file. So you're going to get that county level data on urban, rural, and farm status. And then there's going to be a code book, and that's as a .txt file. And it's going to tell you what all the variables mean. Now, not all the variables will be present in all of the data sets. So you'll see that there's a set of variables that apply to all of the spatial data, but it may not have values for you. So the ones that you're going to really care about in each of your downloads are going to be down at the bottom. So here in table 1, urban, rural, it's telling you that the universe is your total population, and that's going to be that code U7I001. That's your total population for each county. 002 is the number of people who are classified as urban. 003 is the number of people classified as rural, and then 004 is just not defined for the particular data set you've got. So you'll know what that means when you open up your data and try to make some maps in the GIS. So you can see what this looks like here. Again, not all of these fields will have values, and that's okay. The ones that really matter for you are those ones at the end on urban and rural that you're looking at. Okay, so now that you've checked out, you've downloaded your data, well, you've selected your data, you've downloaded it, you've double checked it to make sure it looks correct and like what you need. Now you need to bring it into your GIS. So again, when we did our review, we were just looking at vector data because that's all we've brought in so far. But now we're moving to a new form of data to bring in, and it's delimited text. So here you're going to go down and select delimited text. You're going to tell it what file you want it to bring in up in the file name. And it's going to give you a little sample at the bottom to show you what it looks like. And yeah, that looks correct for us. So it's a CSV file. That's the file format you see up here. And I want to just point out under geometry definition, we are not bringing in, there are no coordinate data. There's no latitude and longitude in this. So there's no geometry. So it's just the data or the attribute only that we're bringing in. Okay, so now you can see that it's added into your layers in your table of contents. It has a new icon. We haven't seen this before. That's a data table. And also of note, when you open it up, you can see that it has this GIS join field. That is a common field across all the NHGIS data that is going to allow you to do these data linkages to bring in your cartographic boundary files, like counties in this case. They'll have a GIS join column. Then bring in all your data. That could be your social drivers data from the US Census. It will also have this GIS join field for the, in this case, the county data. And those are the two unique IDs in those two fields. That's what it'll snap together based on. Okay, so you already had your counties layer in here. Now you've brought in your attributes or your demographic or social drivers data. And if you right click on counties, you're going to go to properties and you're going to click on joins here. You're going to join some data to the file. So your join layer, what you're bringing in is your county level data. The field that you're going to use in this data table is what we just looked at, GIS join, and that is the same, it's the same field in the what they're calling the target field, which is what you want to join to in your cartographic boundary file. Okay, so you go back and you just say, okay, and it should all snap together. So now if you right click on your counties layer and you open the attribute table, you can see that you have all of the original data that came with the cartographic boundary file, but now you're going to see that all of that new demographic data has been added to it as well. When you see this, you know that you're ready to start making a map with this. Okay, so the default for your map, when you bring data in, is a simple fill. So it doesn't, the GIS doesn't know what you want to map. So it just maps everything the same way. You're going to need to go in and change this from single symbol to a graduated symbol. So we want to basically map each county by the percentage of the population who are classified as urban or rural, kind of depending on how you want to set up your map. So we're going to say the value that we want to map is here. If we just even start with the U7I001, that's total population. So if you did that, this is what it's going to give you. It's going to, the mode of classification is equal counts here, quantile. So basically the GIS is just creating what, 5 categories of data from lowest total population to highest total population as an equal count. And you can change the classification methods. You can use natural breaks. That's usually good to get a sense of the natural kind of divisions in your data, kind of the way your data kind of buckets out or distributes itself naturally. None of that generally works very well in communicating publicly. That's where you want to use, if you were just going to map total population, you might use, I don't know, 10,000 as like a defined value. So 0 to 10,000 population, you know, et cetera, doing it in 10,000 chunks. That tends to be more appropriate for presenting the data publicly. It tends to make more sense to people. Likewise, when we move to mapping percentages, you know, doing it in chunks, 10%, 20%, 25%, tends to make more sense to people in terms of making maps digestible to them. So here, if we just said, okay, let's just map in quantile method, the total population, you know, we'll get one map. It's probably not going to be that useful other than just, you know, thinking about social drivers. So we probably want to do something more specific where maybe we want to look at, you know, maybe the percentage of the population who classify themselves as rural. That might be interesting to us. So to do something a little bit more bespoke, you can go in and use the calculate expression, just like we've done before with querying. You can use the expression builder to create your map. So here, what we want to do is maybe we want to say, we want to see we want to see the percentage of the population who are classed as rural for each county. So here I'm going to say double click 003, which is rural population, divided by 001, which is total population. It's going to give us a percentage. And now you can see here that, and this is done in natural breaks, these are kind of the natural chunks of percentages of the population who are classed as rural. that is going to give us a certain map. Again, here we get, it's going to like 0 to basically 24%, a little over 24 to 47%, etc. You can clearly see using natural breaks, Atlanta show up as a very low percentage population, or the Atlanta metro region, a low percentage population of rural, but you can now start to see the patterns show up across the state of where you have the lows and the highs, which is what you want to be able to get out of this type of choropleth mapping or color by area mapping. We can go that next step further and clean up the map and make kind of some clean categories in like 20 or 25% classifications, but this is really where it comes, it comes down to your preference, knowing your audience and kind of how they expect to see your data. But here is basically the workflow of how beginning to do those linkages of bringing in external data that's just in tables, spreadsheets, and linking it to cartographic boundary files so we can start to build pictures of how social drivers and eventually environmental drivers may be linked to our patients and their health. Okay,